We'll take a look at these 4 different examples, and then we're going to practice using our exponent rule. So we're going to express as a product of prime factors. If you're wondering, well, what does that mean here? Let's just do it with the numbers here. 36 times 108. I don't want you to just compute that. We're going to practice breaking this down. 36 is 6 times 6, but those are not prime because we can further break them down into 2 times 3, of which are prime. All right, 108, we could do this a bunch of ways. Let's just go 2 and 54, and with the 54, we could do 6 times 9, and then, all right, that's as far as we can go. So these are prime factors because they cannot be further divided. And we could write this as 2 times 3 times 2 times 3 times 2 times 2 times 3, but we're not going to do that. That's not the goal. Instead, we're going to express this as 2. We've got 2's and 3's. The amount of 2's that are repeatedly multiplied is 4 of them, and then the amount of 3's is 5, and that's the exercise. So you're practicing rewriting your numbers and getting to know all your numbers a little better, practicing your exponent rules. Moving right along here, same thing. Now we'll throw an x into this. But you can think of this as 2 times 7 is the 14 times x, that's 14 x's, and that's multiplied by 25 x's. And then the 24, let's do 3 and 8, but then 2, 2, and 2. All right, so this is 3 times 2 times 2 times 2 times an x. And then if we write what we have here, let's just go 2 to the 4th power. There's 4 factors of 2. There's a factor of 3, there's 2 factors of 5, there's a factor of 7, and then there's 3 factors of x. And that's the goal here. We're going to practice it like that. Next one is the first one where you encounter a little bit different scenario here with the root. You've got the square root, and you call this the 4th root. One thing you should know that the square root is equivalent to the 1/2 power, and the 4th root, by extension here, that's equivalent to the 1/4 power. And if you want one more by contrast here, let's just make one up. If there was a 12 there, then this would be x to the 1/12 power. So well, how come I see the 4, I see the 12. This one, nobody ever writes it because it's so frequently used, but it has a 2, and now you can kind of see what the pattern is. And just a brief moment here, what that means, let's say 100. Square root of 100 is 10 because you can divide 100 into 2 factors. You divide it in half in a timesy kind of way into the factors of 10. So anyway, think of it as dividing. Now this dividing in this sort of timesy sort of way, 32 doesn't divide cleanly in half in this timesy kind of way. So we'll just leave it like that. Now, we do have, I notice that these match, and when those match, we can add the exponents together, but 1/2 is 2/4. I do require a common denominator to be able to do this. All right, so this is 32 to the 3/4 power. We can leave it like that, but we're going to practice doing our prime factoring. So 32 is 2 times 16, and then maybe 16 is, so 32 is 2 to the 5th power. We'll just replace 32 with 2 to the 5th, and then write it like this. Now, just a moment here, maybe I went over this. How come I'm allowed to add these? Why do I get to do that? And so, with a easier problem, like 2 to this 2 squared times 2 to the 3rd power, what does that make here? This is 2 times 2 times 2 times 2 times 2. It's 2 squared, 2 cubed. Well, you can see, well, that's equivalent to 2 to the 5th power. And so the rule, when the base is, that's a big number, when that matches, you just add the exponents. So I did that here, but I required a common denominator. All right, next thing, what about here? What do I do when it looks like this? Because that's a different setup than this rule. So in this case, I'm going to multiply them, and I need to multiply, just do it on the side, 5 times 3/4, and I'll make it a fraction here. We know how to multiply fractions, just across the top, across the bottom, And so this is 2 to the 15/4, and that's what we're going to practice with this. So we've got to get comfortable converting the roots into fractions, equivalent exponents, and then using them to sort of reduce the number. That's the answer, and then let's just discuss here, well, why was I allowed to multiply in a problem like that? And go back to our 2's. 2 squared cubed is 2 squared times 2 squared times 2 squared. That's 1, 2, 3 factors of the same thing. But each of these is squared, so really it looks like this. And then you can say, well, that's 6 factors of 2, and then that's the rule. It's when it looks like this, you've got a number to a power to another power. That's the multiply, which is what we did here, 5 times 3/4.